Hello everyone. Please note that this is a NotebookLM video presentation. Thank you NotebookLM. Hope you find it useful.
Have you ever wondered what a chaotic stock market, a super efficient city, and an ancient myth could possibly have in common? Well, today we're diving into the hidden science that connects them all. It's a science that shows us why some things are perfectly predictable and others are just fundamentally unknowable. Okay, let's just jump right into the heart of it with this question. Think about it. Using the fixed laws of physics, we can predict the exact second of an eclipse decades from now. And yet we often can't predict a traffic jam, a system that we created more than a few minutes ahead of time. So what's the deal here? This is what we can call the predictability paradox. And the answer isn't about how many moving parts there are. Not at all. It's about the type of system we're looking at. There's this massive fundamental difference between something that is merely complicated and something that is truly complex. So first up, let's talk about a complicated system. A jet engine is the perfect example. Thousands upon thousands of parts, all working together. It's incredibly intricate for sure, but here's the key. The rules are fixed. Every part interacts with every other part in a completely predetermined way. You can always go back to the blueprint. Yeah, you can really think of it like a one-way street. You have these fixed interactions, those are the rules of the system, and those rules directly determine the outcome. It might be a really, really long process, but if you know the starting point and you know the rules, the destination is guaranteed. All right, now let's completely switch gears and talk about a complex system. Here, the parts and their interactions are constantly changing each other. There's no central command, no fixed blueprint. Just imagine a flock of starlings in the sky. Each bird is only reacting to its immediate neighbors. But out of those simple local interactions, this beautiful, unpredictable pattern emerges for the entire flock. It's amazing. So what's the secret ingredient that's driving all this? Well, you can pretty much sum it up in one powerful word: coevolution. Honestly, if you can wrap your head around this one idea, you basically understand the engine behind all complexity. This whole process is a constant feedback loop. The state of the parts, let's say the opinions of people in a social network, that influences how they interact with each other. But then those very interactions turn around and change their opinions. It's this total chicken and egg dynamic where the cause and the effect get completely tangled up with each other. So let's just put them side by side to make it crystal clear. Complicated systems, they follow a fixed blueprint. They're predictable, just like a machine. Complex systems, there's no boss, no central control. Their parts and their interactions all co-evolve, and that leads to this wild, unpredictable, emergent behavior. The traffic jam isn't predictable because every single driver's decision changes the interactions for all the other drivers in a constant unfolding feedback loop. Okay, now that we have this new lens, let's see how it changes the way we see the world. Because I'm telling you, you start seeing complex systems everywhere, from the way our cities grow to the hidden structure of ancient stories. Take how cities grow, for instance. If you double a city's population, you don't actually need double the gas stations or roads. Infrastructure scales slower than the population. That's what we call sublinear scaling. But here's where it gets amazing. When it comes to social creativity, you get more than double the patents in innovation. Those social interactions scale superlinearly, and that is a classic signature of a complex system hard at work. And this way of thinking isn't just for urban planning. The same kind of analysis of social networks can be applied to the humanities, and the results are just fascinating. Physicists have even started mapping out the social networks that are described in ancient myths. Let's talk about the famous Anglo-Saxon epic Beowulf. For centuries, scholars have been debating its historical accuracy. Well, network analysis offers a brand new clue, and it's summed up beautifully in this quote. The hero might be fiction, but the society he lived in, that just might be the real deal. So here's how they figured this out. Real-world social networks have a property called assortativity, which is a fancy way of saying that popular people tend to be connected to other popular people. It's a natural feature of how we form societies. The network in Beowulf, though, it wasn't assortative. But then the analysts did something absolutely brilliant. They computationally removed just the main character, Beowulf, and instantly the network snapped into a realistic assortative structure. This suggests that the hero may have been a literary invention just dropped into an otherwise accurate picture of a real society. How cool is that? When you step back, what all of this really points to is a huge new territory for science. The study of complex systems is applying the rigorous methods of physics to questions we've never been able to answer before. going way beyond the traditional world of atoms and planets. This quote from the source paper just captures the grand vision so well. The science of complex systems expands our whole definition of matter to be anything with a state, and interactions to be anything that can change that state. It's a true extension of physics right into the fabric of our everyday lives. So I'll leave you with this question to think about. Where do you see these feedback loops playing out? In your workplace, your social life, maybe even in the evolution of your own ideas? What part of your world is not just complicated, but is truly, deeply, and beautifully complex?